Good morning, everyone. Today we will be presenting our project on thermoelectric energy conversion using a thermoelectric generator, which is also known as the TEG. A TEG is a device that converts heat into electrical energy using thermoelectric principles. We use a buzzer to indicate power generation. So the way it works is it is based off the seat-back effect, where when there is a temperature difference between two materials, an electrical voltage is generated. In our setup, a candle acts as the heating source while the ice acts as the cooling source, which creates a temperature gradients that generates electricity to power the buzzer. Our objective is to demonstrate how heat can be directly converted into electricity and explore efficiency of TEGs in small-scale applications. This process allows the second law of thermodynamics, where heat naturally flows from a hotter region to a colder region, enabling power generation. The thermoelectric generation have real-world applications, including waste heat recovery from factories and vehicles, off-grid power solutions, and even space explorations, where NASA uses them to power spacecrafts like the Mars rovers. To understand the thermodynamics principles behind this process better, my friend will now explain the key concepts that make this possible.
My name is Muhammad Adidinal bin Muhammad Azlan, and I will explain on thermodynamic concept. In this project, we apply key thermodynamic principles to convert heat into electricity using a thermoelectric generator (TEG). The first law of thermodynamics, or the law of energy conservation, states that the energy cannot be created or destroyed, only transferred or converted. Here, heat energy from the candle is transferred to the hot side of the TEG, while the cool side is cooled by ice. This temperature difference allows part of the heat energy to be converted into electrical energy, which powers the buzzer. However, not all the heat is converted into useful work. Some is lost to the surrounding following the equation Q in equal to W out plus Q loss. The second law of thermodynamics states that heat flows from a higher temperature to a lower temperature, creating energy transfer. In this system, heat from the candle moves to the TEG hot side, while the cool side stay cool with the ice. Since not all the heat is converted into electricity, some energy is lost as with heat, increasing entropy in the surrounding. This energy conversion process is based on the seat-back effect, which states that when there is temperature difference between two materials, an electrical voltage is generated. The greater the temperature difference, the more efficient the energy conversion. The process works as follows. Heat from the candle warms one side of TEG, while the other side remains cooler due to the ice. Maintaining a temperature gradient, this difference allows the TEG to generate electricity, which then powers the buzzer. In summary, this project demonstrates how heat energy can be converted into electricity by applying the first and second law of thermodynamics, along with the seat-back effect. The highlight real energy conversion and the importance of temperature gradients in power generation.
Okay, let's move on to the next part. This technology isn't just for experiments, it has a real-world use. For the first one, waste heat recovery. Machines like car engines and factories produce extra heat, right? Instead of wasting it, thermoelectric generator can turn it into electricity. This helps improve fuel efficiency in cars and make factories more energy efficient. Second, space exploration. NASA used TEG in space mission like the Mars rover to generate power from the heat, since there are no reliable sunlight in deep space. Third, emergency power. In disaster area or remote location, TEG can provide electricity using just fire or heat sources. They can charge more devices and power the essential equipment. Why it matters? By converting waste heat into electricity, TEG helps save energy, reduce waste, and provide power where it's needed the most.
First, we put the thermoelectric generator on top of a surface. Then we connect the wires to the buzzer. And then we can have the candle lit. And place it under the thermoelectric generator for it to heat up first. When it reaches a certain temperature,
2,000 years later.
so now it reaches a high temperature. Let's put the ice on top of it.
Next, let's continue with our working mechanism. So, our design operates based on the thermoelectric principle, transforming heat into electricity using a temperature difference. So, the first one, heat exhaustion. When the candle is lit, it transfers heat to one side of the thermoelectric module, while the other one stays cooler due to surrounding air. So this temperature difference is essential for generating our electricity. So the next one, electricity generation. As we use the TEG means thermoelectric generator. As heat flows from the hot side to the cool side, the TEG module converts this thermal energy into electric energy through the Seebeck effect, producing a small voltage. And the next one, continuous energy cycle. As long as the temperature difference is maintained, the module continues to generate electricity. The greater difference, the higher the power output. That's why we use the other side with the ice, because we want to make it the difference of temperature larger. And the last one, the generated electricity travels through the wire to the buzzer, and it produces the buzz sound.
Hello, my name is Sharzan Angelo. So for the conclusion, our thermal energy generator demonstrates a simple yet powerful way to convert heat into electricity using the Seebeck effect. By harnessing the temperature difference between a heated and a cooler surface, we generate electrical energy without any moving parts or complex machinery. This concept is not just limited to small-scale demonstration. In the real world, thermoelectric technology is used in power plants to recover waste heat, in spacecraft like Mars rovers to generate electricity, and even in wearable devices that use body heat to power small electronics. Through this project, we can see how fundamental thermodynamics principles play a crucial role in energy conversion. Our model proves that even a small heat source, like a candle, can produce enough electricity to power a device. In this case, a buzzer. Imagine the possibilities when scaled up to larger systems. These experiments serve as a reminder that energy is all around us, and with the technology, we can make use of waste heat to create sustainable and efficient power solutions. So that is all from our group. Thank you for listening.